everyday. Bismillah ar-Rahman ar-Rahim. We are studying the environmental pathology, and today's topic is malnutrition. An appropriate balanced diet should provide sufficient energy in the form of carbohydrates, fats and proteins, essential and non-essential amino acids, fatty acids, vitamins and minerals. In primary malnutrition, one or all of these components are missing from the diet. In secondary or conditioned malnutrition, the supply of nutrients is adequate, but the malnutrition results from nutrient malabsorption, impaired nutrient utilization or storage, excess nutrient losses, or increased need for nutrients as in infancy and childhood, pregnancy and convalescence. General causes of malnutrition in society include ignorance and poverty, chronic alcoholism, self-imposed dietary restriction, parenteral nutrition, and specific drug therapies. There are three types of malnutrition: protein energy malnutrition. It refers to a range of clinical syndromes characterized by an inadequate dietary intake of proteins, calories to meet the body's demands. Here, two entities exist. Marasmus refers to malnutrition caused primarily by severe reduction in caloric intake. Its second, kwashiorkor, is a more severe form of malnutrition associated with severe loss of visceral protein compartment, and the resultant hypoalbuminemia gives rise to generalized dependent edema with weight up to 60 to 80% of normal. Anorexia nervosa and bulimia. Anorexia nervosa is a self-induced starvation resulting in hard weight loss. Bulimia is a condition in which the patient binges on food and then induces vomiting. The clinical findings in bulimia are similar to those in severe protein energy malnutrition. The major medical complications relate to continual induced vomiting and include electrolyte imbalance, mainly hypokalemia, leading to cardiac arrhythmias, pulmonary aspiration of gastric components, and esophageal and cardiac rupture. Then we come to vitamin deficiencies. Vitamins necessary for human health are 13, fat soluble 4, A, D, E, and K. Water soluble, there are 9, including vitamin C, B1, thiamine, B2, riboflavin, niacin, B6, pyridoxine, B12, folate, pantothenic acid, and biotin. Endogenously synthesized vitamins, vitamin D from precursor steroids, and vitamin K and biotin by the intestinal flora, and niacin from tryptophan and essential amino acid. Causes of vitamin deficiencies: there are primary, dietary in origin, part of protein energy malnutrition, and secondary, because of disturbances in intestinal absorption, then transport in the blood, tissue storage, or metabolic conversion. This table shows the major functions and deficiency syndromes of the vitamin deficiencies. Fat soluble vitamins, vitamin A component of vision pigment, maintenance of specialized bacteria, maintenance of resistance to infection, and deficiency syndromes will be night blindness, xerophthalmia, blindness, squamous metaplasia, vulnerability to infection, particularly measles. Vitamin D facilitates intestinal absorption of calcium and phosphorus and mineralization of bone. The deficiencies cause rickets in children and osteomalacia in adults. Fat-soluble vitamin E, this major antioxidant, scavenges free radicals, and deficiency syndrome causes spinocerebellar degeneration. Vitamin K, it is a cofactor in hepatic carboxylation of procoagulant factors 2, prothrombin 7, 9 and 10, and protein C and protein S. And deficiency will cause bleeding diaphysis. Water soluble vitamins B1, thiamine, as pyrophosphate is coenzyme in carboxylation reactions, and deficiency causes dry and wet beriberi, Wernicke syndrome, and Korsakoff syndrome. Then vitamin B12, also water-soluble vitamin, functions converted to coenzyme flavin, mononucleotide and flavin, adenine dinucleotide, cofactors for many enzymes in intermediary metabolism. Deficiency syndrome, riboflavinosis, chelosis, stomatitis, glossitis, dermatitis, corneal vascularization. Niacin incorporated into nicotinamide, adenine dinucleotide, NAD, and NAD phosphate involved in a variety of redox reactions. Deficiency causes pellagra, 3Ds, dementia, dermatitis, and diarrhea. Vitamin B6, pyridoxine, derivative serves as coenzyme to many intermediate reactions, and deficiency causes chelosis, glossitis, dermatitis, peripheral neuropathy. Vitamin B12 required for normal folate metabolism and DNA synthesis, maintenance of myelinization of spinal cord tracts. And deficiency causes combined system disease, megaloblastic or pernicious anemia, and degeneration of posterolateral spinal cord tracts. Vitamin C serves in many oxidation redox reactions and hydroxylation of collagen. Deficiency causes scurvy. Folate essential for transfer and use of one carbon unit in DNA synthesis, and deficiency causes megaloblastic anemia and neural tube defects. Pantothenic acid incorporated in coenzyme A, and deficiency causes no non-experimental syndrome recognized. Biotin cofactor in carboxylation reactions. There is no clearly defined clinical syndrome. Now we come to the trace elements and deficiency syndromes. Zinc, it is component of enzymes, principally oxidases, and basis of deficiency, inadequate supplementation in artificial diets, and clinical features. There is rash around eyes, mouth, nose, and anus called acrodermatitis enteropathica. Then there is interference with absorption by other dietary constituents and inbound errors of metabolism, and deficiency causes anemia, anorexia, and diarrhea, growth reduction in children, depressed mental function, depressed wound healing and immune response, impaired night vision, and infertility. Iron, which is essential component of hemoglobin, as well as several iron-containing metalloenzymes. Basis of deficiency, inadequate diet, and chronic blood loss. Then clinical features include hypochromic microcytic anemia. Iodine, component of thyroid hormone, inadequate supply in food and water may be the basis of deficiency, and clinical features goiter and hypothyroidism. Copper, component of cytochrome oxidase, dopamine butyrhydroxylase, tyrosinase, acyl oxidase, and unknown enzyme involved in cross-linking collagen. Deficiency, inadequate supplementation in artificial diet and interference with absorption, and clinical features include muscle weakness, neurologic defects, and abnormal collagen cross-linking. Fluoride, mechanism unknown, and deficiency occurs due to inadequate supply in soil and water and inadequate supplementation, and that in deficiency causes dental caries. Selenium, its component of glutathione peroxidase, and deficiency occurs because of inadequate amounts in soil and water, and deficiency causes myopathy. Obesity is defined as an accumulation of adipose tissue that is of sufficient margin magnitude to impair health. Obesity is a disease of caloric imbalance that results from an excess intake of calories above their consumption by the body. Obesity will not occur without intake of excess food. Excess body weight is best assessed by the body mass index (BMI), that is ratio between the body weight and surface area of the body, and expressed as kg per meter square. Obesity class, BMI and disease risk. Underweight, BMI less than 18 kg per square meter, and disease risk increased. Normal BMI 18.5 to 25 kg per square meter, and it's normal. Overweight 25 to 30 kg per meter square, and disease risk is increased. Obese 30 to 35 kg per body meter square, and disease risk high. Very obese 30 to 35 kg per square meter, disease risk very high, and extremely obese mostly more than 40 kg per meter square, and disease risk is highest. Consequences of obesity: central or visceral obesity, in which fat accumulates in the trunk and the abdominal cavity, in mesentery and around viscera, is associated with a much higher risk for several diseases than is excess accumulation of fat diffusely in subcutaneous tissue. The risk of developing hypertension among previously normotensive increases proportionately with weight. Consequences of obesity: non-alcoholic steatohepatitis is common associated with obesity and type 2 diabetes, cholelithiasis, gallstones, hyperventilation syndrome in very obese persons, development of degenerative joint disease like osteoarthritis. Obesity increases the risk of ischemic strokes. This is regulation of energy balance. Regulation of energy balance, it has three main components. Afferent signals provided mostly by insulin, leptin, ghrelin, and peptide YY. Central hypothalamic melanocortin system, which integrates afferent signals and triggers the efferent signals. The efferent signals that control energy balance. Effect of diet on disease. Dietary sodium restriction helps hypertension control. Dietary fiber by increasing fecal bulk has preventive effect against diverticulosis and cancer of the colon. And caloric restriction increases lifespan in experimental animals. Garlic intake is associated with beneficial effects against heart disease. So, diet in cancer, very attractive topic. The role of diet with respect to carcinogenesis is of the following aspects. Content of exogenous carcinogenesis, for example, hepatotoxin in hepatocellular carcinoma. Endogenous synthesis of carcinogens from the dietary components like nitrosamines and nitrosamides formed from nitrites, sodium nitrite, a preservative. In lack of protective factors, high animal fat and low fiber associated with the C. coli, and vitamin C, E, and beta carotenes and selenium have anti-carcinogenic effect because of antioxidant properties. That finishes the topic of experimental pathology, and thank you very much.